Hi folks, this is Nat, and this is going to be a video lesson on how to calculate area and perimeter for rectangles and triangles. We're going to start off with perimeter. Hopefully this is a little bit of review, but in a lot of ways it's the simplest thing because we basically are just trying to measure the outside of a shape. It's a measurement of length, and to get that measurement of length, we really have to know all the different side lengths. So if you don't have all the different side lengths, or you don't have a way of getting all the different side lengths, then you wouldn't be able to calculate perimeter. The other thing I'll add to that is that it's basically always a sum. We're just going to be adding the different side lengths together to find the total perimeter. Let's say for a second that I want to find the perimeter of this rectangle here, and I can tell that one side is 3 1/4 and one side is 5 3/8. Sometimes students make the mistake of thinking they can't figure out the perimeter from the information they have, but if you're looking at a rectangle, it's important to kind of remember those rectangle qualities where opposite sides will have the same length. The same thing would be true for, say, a rhombus or a parallelogram generally. So if you see 3 1/4 on one side, you know that the opposite side is 3 1/4 as well. And if you see 5 3/8, you know that 5 3/8 is also the measurement of the other side. And you just have to add these up. So I'll end up doing 5 3/8 plus 5 3/8 plus 3 1/4 plus 3 1/4. Now, hopefully we remember adding mixed numbers, and in this case it would be very helpful to me if I had a common denominator to add these up with. So I would probably go ahead and change 3 1/4 to 3 2/8, and I'd do that twice so that I had all 8s. And then I could add up all my 8s and all my whole values, and I'd have my answer. So I've got 3 8s, 3 8s, that's 6 8s, plus 2 8s, that's 8 8s, plus 2 8s, that's 10 8s. So I have 10 8s total. And then I've got 5 and 5 is 10, and 3 and 3 is another 16. So 16 10 8s. That's an okay answer. It is the total, but it's not in proper form. I have that improper mixed number there. So I'm going to pull 8 8s from my 10 8s, and I'll make it 17 2/8, or 17 1/4. And that would be the total perimeter for that rectangle. The same thing would more or less be the case for my triangle over here on the right. Let's say I know that one side's 4 inches, one side's 3 1/3, one side's 2 5/6 inches. Again, I'm just going to add these up, and that'll give me my total perimeter. So I'll do 4 plus 3 1/3 plus 2 5/6. And again, I want to have a common denominator, so I'm actually not going to keep that 1/3 as a third. I'm going to change it to sixths so that it matches since I can. I'll multiply both the numerator and the denominator by 2. And I'm going to say that that is 2 sixths. And I'm good to add that up. So I've got 2 6 and 5 6 makes 7 sixths. And I've got 4 plus 3 plus 2 makes 9. So this is 9 7 sixths. Now again, I can't just leave it as an improper mixed number. I'll take 6 sixths more away from 7 sixths, and it's going to be 10 1/6. So a grand total of 10 1/6 perimeter. And that's more or less all there is to perimeter. Area tends to be the thing that gives people more trouble conceptually. It's sometimes easier to calculate, but people have a hard time kind of understanding what area is. So we're going to take a second to talk about that in case you never have before. And let's begin with an example. Let's say that I've got a rectangular space that is 4 meters wide and 6 meters long. Area is measured in square units, and those units can look like a lot of things, but it's basically according to whatever measurement you take your lengths in. So if I'm measuring in meters, 4 meters and 6 meters, then my unit is going to be a square meter. And what that means is that I'm basically saying how many little squares will fit into this space. Because unlike length, a square takes up space, or area takes up space, whereas length does not. So you need something that takes up space, like a square. So we're thinking like flat two-dimensional squares. So when we take the area, we're saying, okay, 6 meters long. I'm basically saying that I'm dividing that space into 6 meters that way, and then 4 meters in the other direction. And every square that's divided up is going to be 1 meter by 1 meter. That's a square meter, or a meter squared. And we're saying how many of those are there? In this case, there would be 24, if you counted them up. There's a lot of faster ways to do that. In fact, multiplication is pretty much what we're going to do here. But anytime you think about area, you should definitely know that it's a measurement of how many squares fit inside of a space. Same thing if you're talking about other shapes. If I'm talking about a triangle that's 3 by 3 inches, I'm going to divide that area up into, 3 inches worth of segments. Okay? And it's going to end up looking something like this. This is not a great drawing, but this is what it's going to look like. And again, even though the shape doesn't fit with squares in it, we're basically saying how many of these squares are actually going to fit in there. There's 1, 2, 3 whole ones, and then 3 halves here. It ends up being 4.5 squares. So that triangle would have an area of 4.5 square inches. And that's kind of what you're doing whenever you calculate area. So then there's the how to calculate it, and that really depends on what it is that you are, what shape you're trying to calculate with. A rectangle is functionally the beginning point of most area. So we're going to start with the rectangle. And if I want the area of a rectangle, all I'm really doing is saying that the area is going to be equal to either the length times the width, or you might also hear it said as base times height. And either way you want to talk about that, those are basically just the two aspects of the area, or of the rectangle. One of the sides is going to be the base, one's going to be the height, or one will be the length and one will be the width. And we're just going to multiply those two things together. That'll give us the area of a rectangle. So to kind of continue our example, let's say that this particular rectangle has a width of 2.5 or a height of 2.5, and then has a base or length of 3 3/4. To find the area of that rectangle, I just have to say 2.5 times 3 3/4, which is a multiplication of mixed number things, so we've got a couple other steps involved here, but that's basically going to give me the area. To multiply the mixed numbers, I have to convert them to improper fractions. I can't leave them as mixed numbers. So 2.5 is going to become 5 halves, and 3 3/4 is going to become 15 quarters. If you don't remember how to do this, I'll give you a quick overview again. Basically, the denominator never changes. To get the new numerator, I multiply the whole number by the denominator value, and I add the numerator. So 2.5 becomes 5 halves because 2 times 2 is 4, plus 1 is 5. So 5 halves. Again, the halves stays the same. Same thing over here with 3 3/4. 3 times 4 is 12, and if I add the 3, that's 15. 15 quarters. The quarters part stays the same. And now I'm ready to multiply. 5 halves times 15 fourths. Straight across is going to be 75 eighths. And there really isn't any reduction I can do here. I might want to turn my answer back into a mixed number. I may not. If I did, in this case, it would be 9 3/8, because 8 goes into 75 9 times, with 3/8 remaining. The other sort of area we're going to worry about today is the area of triangles. And the area of triangles tends to mess kids up for a couple reasons, but it can be a little trickier because we don't just use the perimeter information, like the lengths of the sides, and multiply those together. When we do a triangle, we're looking for really specific information. We're looking for a right angle. So lots of times we'll see a triangle like this, and we'll see that it's got a right angle drawn into the center of it. And that's going to be the height of the triangle. Let's say in this case that the height is 3. The other information we need when we're dealing with triangles and trying to find their area is what's called the base. And the base is going to be the other side of the triangle, the actual length of a side of the triangle attached to that right angle. So in this case, the base would be right here on the bottom. Let's say that was 7. I use that information to calculate the area like this. Area in a triangle is going to be half the base times the height, or 1/2 times the base times the height. So if the base is 7 and the height is 3, the base times the height is 21. Half that is going to be 10.5, so the area of this triangle would be 10.5. It's important to recognize that the information you want, it's kind of irrelevant which is the base and which is the height. What we're looking for really specifically is the 90-degree angle. The two pieces of information on the 90-degree angle are always going to be the ones we want. So regardless of how the triangle is oriented, I'm looking for that 90-degree angle, and I'm looking for the two bits of information on it. So here are two more quick examples to help us kind of illustrate this idea. If we look at the one on the left, again, I'm looking for that right angle, and here it is. Regardless of whether the right angle is in or outside the triangle, that's the information I want. So this 3 along the base and this 2 1/3 along the height are going to be the important pieces of information. And I'll just do 1/2 times 3 times 2 1/3. And I'll do some conversions there to make that easier. 1/2 can stay the same. 3 is going to be 3 wholes, or 3/1. And 2 1/3 is going to need to be converted. 2 times 3 is 6, plus 1 is 7. So it's going to be 7/3. And I can just multiply straight across. 3 times 7 times 1 is 21, and 2 times 1 times 3 is 6. I'll want to reduce that down, first of all, to 7/2, and then I'm going to convert that back to a mixed number in this case, just in case I'd want to. And that's 3.5. I included this example over here because it sort of illustrates the idea that the right angle is the important information no matter which way the triangle is oriented. It would be super common for kids to multiply a 5 in here, but we don't want to. If we look again, here's our right angle, and so the sides on the right angle, in this case it's a right triangle, so I want the two sides. Those are the things I care about, the 3 and the 4. Those are the base and the height. So I'm going to do 1/2 times 3 times 4. And I could do this a lot of different ways, but I'm going to say 3 times 4 is 12, and 1/2 times 12 is going to be 6. So this triangle is going to have an area of 6. And the other information I'll give you just in case you were wondering is why is it that we always have the area of triangles? And the answer to that is because a triangle always takes up exactly half of the rectangle that it could be inside of. So if we look at this example, here's a whole rectangle with a length and a width, or a base and a height, of 3/4. That's 12. And we can see really clearly that the triangle takes up exactly half that space, so it's half of 12, which gets us to our 6. And here are your practice problems for the lesson. There's only 2 of them, but for each of these you need to find both the area and the perimeter. If you need a review on how to add or multiply with mixed numbers, I will attach a link in the assignment so that you can review that if you need to. Good luck.